Good morning, students. We are discussing kinematics. Yesterday we started kinematics. Now we see some definitions: distance, displacement, velocity, accelerations. So first I explained the translatory motion. Okay? So translatory motion. So what is this translatory motion? The rigid body consists of many particles. If all the particles of the body, the motion is in a similar fashion, that is identical. That means all the particles of the rigid body will have same displacement, same velocity, same acceleration. Then the motion of the whole body represents motion of a particle. So in that body. So if you consider motion of a particle in the body, that will be assumed as motion of the whole body. So here we are using particle or body conveys the same meaning in translatory motion. Okay. So this translatory motion we are classified into two types. The first one is rectilinear motion. Rectilinear motion. The second one is curvilinear motion. So we are classified into two types: rectilinear motion. This rectilinear motion we can also call it as one-dimensional motion. One-dimensional motion. That is, motion is confined in a line only. One-dimensional motion. This curvilinear motion, again we have two types. The first one is curvilinear motion. This is two-dimensional motion. Motion in a plane. Motion in a plane. That will also call it as two-dimensional motion. Two-dimensional motion. Motion in a space. In a space. In a space is three-dimensional motion. Three-dimensional motion. Okay. So the examples for one-dimensional motion is body moves in a straight line. Motion of a car. Motion of a car. Body moves in a straight line. Vertically projected body. Vertically projected body. And a freely falling body. These are the examples we are going to discuss in one-dimensional motion. Two-dimensional motion. Motion of a insect crawls. Insect crawls. Crawling on a floor. Floor or wall. Insects crawling on a floor or wall. Floor is a horizontal plane. Wall is a vertical plane. Both two-dimensional motion. Motion in a space, three-dimensional. Insects flies. Insects flies. Fly in a space. In a space. Football. That is soccer. soccer, that is football. Football in a ground. If ball hit with a foot, the ball will move randomly in any direction. So these are the few examples for three-dimensional motion. These are the problems we are going to discuss in kinematics. So problems we are classified into one-dimensional, two-dimensional, three-dimensional. Okay. Now first we will see this one-dimensional motion. This one-dimensional motion, again we are classified into different types. Okay. This one-dimensional motion, first we are classified into different types. The number one is uniform motion. Uniform motion. Uniform motion. Second one is uniform accelerated motion. Uniform accelerated motion. Third one is uniform retardated motion. Uniform retardation. Retardation motion. And next one is non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. So we are going to discuss this one-dimensional motion first. The first one we will discuss one by one. First one is uniform motion. Second one is uniform accelerated motion. The third one is uniform retardated motion. Fourth one is non-uniform acceleration. These are the things we are going to discuss. Once you understand this one, we can assume this two-dimensional motion and three-dimensional motion as the superimposition, a combination of in two-dimensional, two rectangular rectilinear motions. So we can treat this two and three dimensionals as superimposition of two or three rectilinear motions. So once you understand this, you can solve these problems also. Okay. Now the first one I am going to discuss one by one. The first one is uniform motion. What is a uniform motion? A body moves with uniform velocity. So now I will discuss one by one. Okay. The first one is uniform motion. Body moves with uniform velocity. Moves with uniform velocity. Then motion of the body is said to be uniform motion. That is uniform velocity in the sense magnitude of velocity and direction. Magnitude and direction remains the same. Remains same. That means no change. Magnitude and the direction of direction of velocity. Velocity, magnitude, direction remains same, that is constant. Such a type of motion is called uniform motion. So if you draw a graph, its velocity, then the distance traveled, distance we can travel, we can write it as, distance is equal to, we can write it as speed into time. We can use this formula. Or displacement is equal to velocity into time. So in one dimensional motion, this distance and displacement both are same, speed and velocity are same if a body moves in a straight line. So if you draw a graph, this formula wise we can write it as S is equal to Vt. So S is equal to Vt. This is the first formula in kinematics. Now if you draw a graph for this displacement and time, so this is a S-T graph. It will be uniform velocity, position will changes, displacement, you will get a straight line passing through origin. If starts from origin, if it is not starts from origin, then you will get like this. That means it has certain initial displacement from origin. Let it be S0. So this is ST graph. This is also ST graph. So here, say, I will explain with this one dimensional motion. This is origin. The particle starts from here. So initially it has certain displacement x0. So x0 or s0. This I take it as x0 or s0. Both same. So starts from here when t is equal to 0. Then this, for that, this is the graph. If starts from here, then this is the graph. Okay. So it travels like this in a straight line. So distance after t seconds will be, what is this distance? Let x be the position of the particle after t seconds, x or s. So what is the mathematical equation here? We have s is equal to, for this diagram, s is equal to s0 plus vt. For this one, initial displacement is s0. So or we can write it as x is equal to, if it is one dimensional motion, body moves in a straight line. That we can show on the graph coordinate system on the x-axis. So x represents the position of the particle on x-axis, x0 plus vt. So these are the two corresponding graphs, ST graphs. Suppose you want VT graphs, VT graph. You want to draw VT graph. What is this graph? ST graph. That is ground displacement time graph. VT graph. V is constant here. So you will get this is T velocity. Velocity is positive. Then we can represent like this. If velocity is negative, we can write like this. Negative x-axis. It will be uniform like this. So this is origin. This is also origin. So this is VT graph. Here the velocity is positive. Velocity positive. I said velocity may be positive or negative. Here the velocity is negative. this is negative y-axis. So here velocity is negative. This is the time. Okay, this is positive y-axis, this is negative y-axis. These are the two graphs, VT graphs. I want AT graph. So what is the AT graph? So what is the AT graph? You draw a graph between acceleration and time. So what is the acceleration of this body? If a body moves with uniform motion, what is its acceleration? What is its acceleration? Acceleration is 0. When a body moves with uniform velocity, its acceleration is 0. Okay? So acceleration is 0. So how do you draw this graph? So acceleration is 0 means it will be like this, 0. So acceleration is along the positive x-axis. So it is parallel to x-axis. Acceleration value is 0. So the graph will be like this. Okay, this graph is called AT graph. So here, how many graphs I gave? 2 ST graphs, 2 VT graphs, 1 AT graph. This is for uniform motion. The body is moving with uniform motion. So the next, to discuss this, I will give few examples to understand. Okay. We will do certain problems based on this uniform motion. First problem. A man walks on a straight road. Straight road from his home. To a market. 2.5 kilometers away with a speed 5 kilometers per hour. On reaching the market, he instantly returns and walks back with a speed 7.5 kilometers per hour. what is the first one? Magnitude of average velocity. Magnitude of average velocity. B. Average speed of a man. Average speed of a man. Speed of the man. Over a time intervals. Under that, first one, 0 to 30 minutes, 0 to 50 minutes, 0 to 50 minutes. Third one, 0 to 40 minutes. So this is the problem based on uniform motion. Based on uniform motion. Okay. Now see how we can calculate, how we can solve this problem. A man walks on a straight road. So let it be origin. His home will be at origin. Generally, a person or body starts, we will treat as origin. So I consider this one as the origin, home as origin, and the market, straight road to a market 2.5 kilometers away. So the market is 2.5 kilometers away, moving with a speed V1, moving with a speed V1, how much? 5 kilometers per hour. On reaching the market, he instantly returns and walks back with a speed 7.5 kilometers. So he is again, after reaching the market, instantly return back to home with what speed? 7.5 kilometers per hour. The same distance, now speed increases. So magnitude of average velocity. So the first one is, we want average velocity. Okay. What I said? Average velocity formula. Total distance, total displacement by total time. Total time. So displacement by time. So what is the displacement? Starts from home, go to market, return back to home. So starting point and final points are same. So what is the displacement? 0. So displacement is 0. So average velocity is 0. So this is the answer for first question. Okay. Average speed of the man over a time interval, 0 to 30 minutes. So 30 minutes, how many hours? So 30 minutes is half an hour. So that is, for the first answer is, I want average speed. I want average speed. So I will rub this problem and I will write here. So average speed. So what is the formula for average speed? Distance by time. Total distance by total time interval. So what is the distance traveled in half an hour? So 0 to 30 minutes. So here first one is duration of the time is 0 to 30 minutes. That is half an hour. So time is half an hour. Distance in half an hour, how much distance traveled by this person? For going home to market, it will take he is moving with a speed 2.5 kilometers per hour. 2.5 kilometers with a speed 5 kilometers per hour. So in 1 kilometer, 5 kilometers. In 1 hour he travels. In 1 hour he travels 5 kilometers. In half an hour he travels 2.5 kilometers. So the distance is 2.5 kilometers by time is half an hour. That is 5 kilometers per hour. So the average speed of the person is 5 kilometers per hour during the time interval. Next one is during the time interval 0 to 50. 0 to 50 minutes. So 0 to 50, how many hours? 50 by 60. That is, for going half an hour, it will take 30 minutes. So for going 2.5 kilometers, it will take half an hour. Remaining 20 minutes. So 50 minutes can be written as 30 minutes plus 20 minutes. In 30 minutes, he travels how much distance? 2.5 kilometers. In 20 minutes, how much distance he travels? So in 20 minutes, he travels a distance. Distance traveled in 20 minutes. Distance traveled in 20 minutes. Distance traveled in 30 minutes is how much? 2.5 kilometers. Distance traveled in 20 minutes. So after half an hour he returned back, but speed changes, 7.5 kilometers. 20 minutes means 7.5 kilometers distance traveled, speed into 7.5 into time. Time is 20 by 60 hours. So you will get 3 7.5. So 3 2s 6 15 5. So 2.5 kilometers per hour. So again we got, so the answer, this average speed 2.5 kilometers per hour. Next we want 40 minutes. Okay. Next in 40 minutes duration. So third one, during 40 minutes. So the time is 0 to 40 minutes. In this interval, we want average speed. So this can also be written as 30 minutes for going to the market plus return 10 minutes. Okay. So 30 minutes, distance traveled in 30 minutes is, distance traveled in 30 minutes. The next one is, we want average speed between 0 to 40 minutes. So 0 to 40 minutes, this time we can take it as 0 to 30 minutes 30 minutes plus 10 minutes. Okay, so this duration 40 minutes we will split up into 30 minutes and 10 minutes. So distance traveled in 30 minutes. How much? Distance traveled is speed into time. 30 minutes is half an hour into speed is 5 kilometers per hour. That is 2.5 kilometers. First half an hour he travels. Next 10 minutes he travels how much distance? So 10 minutes speed is 7.5 kilometers into time 10 minutes by 60 minutes, that is 1 by 6, that is 7.5, 75 by 6, 60, that is 15 by 12 kilometers. So that much distance, total distance. We want average speed. Average speed between the intervals, average speed between the intervals 0 to 40. So average speed is total distance by time, total time. So total distance is 2.5 kilometers plus 15 by 12. 15 by 12 is, this is 3, 5 by 4 kilometers. 5 by 4 kilometers. 5 by 4 is 1.25 I think. So by total time 40 minutes. 40 minutes convert into hours, 60 minutes. So this is 2.5 into 4. This is 10. 10 plus 5, 15, 15 by 4 into, this is 3 by 2, 2 by 3, 3 by 2. So this is 45 by 8, average speed. 2.5, this is 10. Total distance is 2.5 kilometers plus 5 by 4, 3 5s, 3 4s, 5 by 4. LCM is 2.5 into 4, that is 10, 10 plus 5, 15 by 4 into, this is total time, hours, 2 by 3, that is 3 by 2. So what you will get? 45 by 8. So average speed is 45 by 8 kilometers per hour. This is the answer. Okay, 45 by 8. That means nearly 8 5s, 5.50, 7 8s. That is 45 by 8. 8 5s, 45, again 50, 8s, 8 8s are 64, 8 5s, 40, 8 6, 48. So nearly 5.6 kilometers per hour. This is, okay, 45 by 8, nearly 5.6 kilometers per hour. So that is average speed between the time interval. So from this problem, what we can conclude? So 0 to this, the conclusion is 0 to 30 minutes, the average speed, and 0 to 30 minutes average speed and average velocity both are same. And during the different intervals, the overall total journey, for total journey average velocity is 0 for total journey. Okay, so this average speed, so what are the points we can conclude? Average speed, average velocity may be equal when they are moving in a straight line. So up to certain time only. Then it is not equal always. Average speed, average velocity are not equal always. So a body moving with uniform speed. Uniform speed may have variable velocity. Variable velocity. A body moves with uniform speed. Body may have variable velocity. That point we can conclude. The next problem. Walking a narrow lane takes 5 steps forwards, 5 steps forward, 3 steps backwards, 3 steps back, 3 steps back, and so on. 3 steps back, again 3 steps backward, followed, again 5 steps forward, 5 steps forward, 3 steps back, 3 steps back, and so on, like that, and so on. Each step 1 meter and requires 1 second, and requires 1 second. Plot xt graph. So we have to plot xt graph of his motion, determine graphically or otherwise how long the drunken takes to fall in a pit. So there is a pit 9 meters away, 9 meters away from start. So this is the problem. Okay. So we have to draw a drunken moving 5 steps forward and 3 steps back, and again 5 steps forward, 3 steps back, and so on. So each step we have to draw a graph for this PT graph, XT graph. X you take it as on y-axis, T is independent variable, you take on x-axis. So X position depends on time, so you take on y-axis. So we have to draw XT graph. Now I am going to draw XT graph. This is XT graph. Okay, I am going to draw. So 5 steps forward. So you take the scale 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 like this. So in 5 steps, 5 seconds he moves forward. So xt graph is a straight line. So in 5 seconds, so from here this 5, from here next 3 seconds, 3 steps back, each step takes 1 second. So 6, 7, 8. So again he moves back 3 steps forwards, 1, 2, 3. So again it will reach us to 2. So it decreases. So it moves like this. So finally after 8 seconds he will be at 2 meters from origin. And again 5 seconds, 9, 10, 11, 12, 13. So again 5 steps. So 5 seconds, 1, 2, 3, 4, 5. So up to 13 seconds he moves forwards 5 steps. So from here 1, 2, 3, 4, 5, 7 meters. So he moves up to 7 meters like this. So 7 meters. So now the time is 13. So it will be like this. So 13. Okay. So 7 meters. 13 seconds. Again he moves back 3 steps. So the time is 19, 14, 15, 16, 3 seconds. So from this 13, 3 seconds, 1, 2, 3, 1, 2, 3. So 16th minute he moves back. How many steps? 3 steps. 1, 2, 3, 1, 2, 3. So again he will be at 5. So he will be at 5. So this is 5. Okay. So he will be at 5. 1, 2, 3. So he will be at 4. 4 meters. So this is 4. So this is the 4. 4 meters from starting. This is 2 meters. Okay. So now the time is, elapsed time is 15 seconds, 16 seconds. So 16 seconds. Now, so first 8 seconds and then again 5, 3, 8 seconds, again 5, 8 plus 5, 13, again 3. 13 plus 3, 16 seconds. So up to time is 16 seconds are over. And again he starts the journey. Okay. So up to 16 seconds he will be at so this is 2, he will be at 4 meters. And then again starts 5 seconds he is moving forwards. So from 4 he is moving forwards 1, 2, 3, 4, 5, 9 meters. So here the pit is here at 9 meters. So here he continues the journey 5 seconds from 16. So 17, 18, 19, 20, 21 seconds. So at 21 seconds, 5 seconds from 16. 16 plus 5, 16 plus 5, 20. So he walks forwards 5 seconds continuously. So from 16 to at the time 21 seconds, he travels far. He will be at the 9th meter. There is a pit. So he will fall. So he will be at 9 meters here. This is 9 meters. So he will fall. So from the graph we can conclude that Now the question is, determine graphically or otherwise how long the drunken takes to fall a pit of 9 meters away. So the answer is, drunken falls, he takes how much time? He takes 21 seconds. How long? 21 seconds. 21 seconds to fall in a pit. In a fall in the pit. So it will take how much time? 21 seconds. 21 seconds. So in the overall, how much distance it travels? Distance he travels. Distance is, see, 5 meters, again 3 meters, 5 meters, 3 meters back, again 5 meters forward, again 3 meters, again 5 meters. So how much total distance? 5 plus 3. So distance travel 5 plus 3, 8, 8 plus 5 plus 3 again. So 16, 8 plus 8, 16 and 5, 21 meters. So the distance traveled is 21 meters. What is the displacement? Displacement is 9 meters. So the distance traveled is always, so the distance traveled is always greater than or equal to displacement. Okay? So these are the points we can conclude. Clear this sum? Next sum. Next sum. Next sum, third sum. On an open ground, a motorist follows a track that turns to left by an angle 60 degrees. After every 500 meters, starting from a given turn, the displacement of the motorcycle, the displacement of the motorist at the third and eighth, sixth and eighth turn. Compare the magnitude of displacement, magnitude of displacement with the total length covered, covered by the motorist, okay. In each case, so you have to compare the distance and displacements in each case, okay. So on an open ground, a motorist follows a track that turns to left by an angle 60 degrees after every 500 meters. So here, every 500 meters, see, this is the 500 meters, let it be x. After 500 meters, he turns 60 degrees to the left, so this side, turns 60 degrees. So this angle is 60 degrees, turns 60 degrees left. So after turning again, he turns 60 degrees. So this is the first turn, this is the second turn. So with this again 60 degrees, he turns left. After traveling 500 meters, again he turns 60 degrees, like this, 60 degrees. So it seems to be 60 degrees. It seems to be regular hexagon, like this, 500 meters. And again turns 60 degrees. So this is again 60 degrees. He turns left. And again 60 degrees. So he reaches here. So this is 60 degrees. This angle, 60 degrees. Like this. So every time he travels a distance x. What is x here? X is 500 meters. What is this x? I take this x is 500 meters. So first turn he starts from A. So he reaches to this point B, first turn. He reaches to the point C, takes the second turn. He reaches the point D, takes the third turn. Point D, third turn. He reaches to the point E and takes the fourth turn. He reaches the point C, D, E, F and takes the fifth turn. Again he reaches to this point. So after, again he will take sixth turn here. Again he will take seventh turn, eighth turn. So 2, 8. This is 3, again 9. Again here 10, 4, 9. Again here 11th turn. Here again 12th turn. Like this. So the motorist will travels in a track like this. So each, after traveling 500 meters, he turns left side, every turn. So like this he is taking the turn on a motorcycle. Okay. Now, what we want? Let it be, this is the each side of the hexagon, let it be x. We want the third, sixth, eighth turns, we want displacement, magnitude of the displacements and distances. Okay. So let us see, after this first turn, what is the displacement? So this is the displacement after the first turn. So what is angle between them? Between these two is 60 degrees. So first vector will be like this, second vector will be like this. The vectors are equal and the angle between them is 60 degrees. So you have to add these vectors by using vectors addition. So I said vectors are very important. So this vector addition we have to add. So if two vectors, so P and Q, if AB are two vectors, the magnitudes are equal and the angle between them is theta. Angle between them is theta. Then the resultant is, if there are two equal vectors, angle between them is theta, then what is the resultant? Resultant is, I said 2a cos theta by 2. So I am using this one, 2a cos theta by 2. So here I am adding first and second vectors. So the displacement is after first term. So after first term, I will write here, turn will be here, displacement, let it be distance. Okay, I want this, I want fill these columns. Okay, first turn, at the end of first turn, displacement is 500 meters, that is x. Displacement is distance is x, 500 meters, that is x. So second term, after second term, let it be x, x. So after second term, what is the displacement? At the second term, what is the displacement? Displacement is, I am using this formula. So what is this formula? 2a cos theta by 2. That is, we can write it as here 2x cos theta by 2. What is theta here? 60. Cos 60 by 2. So what you will get here? Cos 60 by 2 is cos 60 root 3 by 2. So you will get displacement is, I will write here, resultant is 2x cos 30 is root 3 by 2. So you will get a root 3x. So after second term, the displacement is root 3x. X is 500. That is root 3, 500 root 3 meters. 500 root 3 meters or root 3x. That is the displacement. Okay. Now distance. What is the distance? 500 plus 500, 1000. So it is 1000 meters. That is 2x. That is the distance after second term. Now after third term, so he will take the first term, second term, third term here. So what is the displacement? So you have to add the resultant is it will be, so you have to add this one, this vector to this resultant. So it has magnitude root 3. This is I will extend this one. Okay, so this is what is, you have to add this one. So 60 degrees. So with this we have to add 60 degrees. So you extend this one. This vector is resultant. So you add this vector. This magnitude is root 3x and x. So what is angle between them? So angle between them is, you extend this one. This is 60 degrees. You extend this one. So with this horizontal, if this is 60, this will becomes 120. So this is 120. This is also 60. 120 is, this is x. This is x. The resultant will be root 3x. So we have to add to this resultant to this x, that is x. So we have to add. How we can add these two? So you have to find this angle between these two. Here it is 120. This angle is 120. 120 means here this, it seems to be, this angle is 30. This one is 30. So 30 plus 30, it bisects. So it will become 30, 60 plus 120, 180. So sum of the angles in a triangle is 180 degrees. You know that. So here is 120, 30, 30. So it bisects this one. Remaining 60 degrees bisects 30 degrees, 30 degrees. So I am extending this one. So I want to add. Okay. So this is root 3x and this is 30 degrees. So 30 and 60. So this is root 3x. Now the angle between them is 90. So you have to add these two. I will show here how I am adding these two vectors. One is having magnitude root 3x. Other is having magnitude x. Angle between them is 90. So how we can add? By using parallelogram law. Resultant is square root of, here I am using parallelogram law. Addition of vectors, root 3x. So what is the resultant of parallelogram law? A square plus b square plus 2ab cos theta. I am using this formula. Okay. So I want resultant. I want add root 3x and x. Angle between them is 90. So what is the formula? Square root of a square root 3x whole square. So it will become 3x square plus b. B is x square plus cos 90. Cos 90 becomes 0. So what is this value? The resultant is 3x square plus x square. It will become 4x square. That is 2x. So displacement is 2x. I got 2x here after third term. Laps. First lap, second lap, third lap. This is 2x displacement. So 2x. So what is the 2x means? 1000. 2x, that is equal to 1000. 1000 meters displacement. Distance is 500, 500, 500. 1500. So 1500 meters. That is 3x. See the difference between distance and displacement. Displacement is always less than distance. Okay, 3x. So up to here, first term, second term, third term. So the question is, third term. After third term, what is the distance? Compare the distance and displacement. So the answer is, after third term, displacement is 1000, distance is 1500. Okay, 1500. The next one is sixth term. So I will continue like this. Here this, after this fourth term. This is fourth. After fourth, first, second, third. Fourth will be here. So after fourth one, what is the displacement? See, these two get cancelled. Again you will get this. This one will be in this direction. This will be. These two get cancelled. So resultant of these two, angle between them is 60. So you will get again root 3x. So again you will get root 3x. That is 500 root 3. So 500 root 3. So after fourth turn, what is the displacement? Distance 2000 meters. That is 4x. Okay. After fifth turn, I will write here. So turn, distance, displacement, distance, okay. So after fifth turn, say fifth turn, fourth turn will be over, fifth turn will be here. Fifth turn, again, see, these two get cancelled, these two are equal and opposite, get cancelled, these two get cancelled, again you will get, see, fifth turn will be here, we want to add these vectors. So, first add this one and this one get cancelled. This one and this one both are equal and opposite vectors, so they cancel. Again you will get x, only x. So you will get, if the displacement is x, that is 500 meters. 500 meters. Distance traveled is 5 into x, that is 2500 meters. After sixth term, again fifth here. Again after sixth term, displacement is, again he reaches here. So starting point. After first turn, second, third, fourth, fifth, sixth. So that means after six turns he reaches to the starting point. So initial displacement is 0. Displacement is 0. This we can also say in another words. This vector get cancelled. This one and this one get cancelled. This one and this one. Both are equal and opposite vectors. When two vectors are equal magnitude, opposite in direction, so they cancel with each other. 1 pair, 2 pair, 3 pair. So they are cancelled with each other. So distance is 6x. That is 3000 meters. Like this. Then onwards again repeats. So again here 1, again seventh turn. For 1 and 7 you will get the same answer. For 2 and 8 again you will get the same answer. For 6th turn this is the answer. For 8th you will get this is the answer. For 9th you will get 2x. For 10th you will get root 3x. For 11th turn you will get the same answer. For 12th turn you will get the same answer. Like this, every 6 times, 6 laps, these distance and displacements are, distances gradually increases, but displacement repeat its values. Okay? Here you have to note, distances will add, but displacement you will get the same answer. Distance goes on increasing. Every turn, distance increases by 500 meters. Keep this point in mind. But displacement repeats. After every 6 laps, you will repeat the same thing. Okay? This is the problem. This is the solution for this problem. Okay? Clear?